What is momentum by Dyer physics? Relationship with mass and velocity is given by mass into velocity, velocity with the unit of meters per second and mass in the unit of kg. Then the momentum unit will become kg ms minus 1, and it also a vector quantity which has direction and magnitude. It has a direction and magnitude. Don't forget that. Now we'll take this example. A small spacecraft engine floats at rest. So the initial momentum is zero. Cushion of air. The spacecraft engine ejects large number of xenon ions to left. A mass is given and speed is given. So gas eject back, right, to the left. So with the mass of 2.6 into 10 to the power 8 minus, and with the velocity of 26 kilometers per second. So asking the momentum of the ejected xenon. So what we have to do, multiply the mass, that is this one, multiplied by this. What you have to make sure that it is meters per second it should be. So 26 kilometers per second must be multiplied by 1000 to make it meters per second. So you get the answer as 6.8 into 10 to the power minus 4 kg ms minus 1, kg ms minus 1, right? That is to the left. So which direction the spacecraft will move? Forward, that is to the right. As initial momentum is zero, as it is rest, it was rest at the beginning, so the final momentum also should be zero. So the eject gas having 6.8 into the power minus 4 momentum, so the spacecraft is having same momentum to the right. So law of conservation of momentum says that total momentum before equal total momentum after, unless no resultant force act. So that's why earlier you get these two moments equal, because initial momentum is zero, so the final also should be zero. That's why it is back and forward, same and opposite. So then this is the question that you can arise. State the magnitude and direction of the spacecraft. So gas, we have the momentum as 6.8 into 10 to the power minus 4 kg ms minus 1. So it is to the left, so the spacecraft will move forward, that is to the right. So the relationship between force, change in momentum and time taken is given by this. Change in momentum divided by time taken is the force. So final momentum minus initial momentum is the change, and the time taken is t. So this can be described as the mass into acceleration, because v minus u over t is the acceleration. So this is famous F equal ma equation relationship. So this t, we can say that acceleration time, or if it is deceleration time, right? So here the same example, the gas exert a force of 2.6 millinewton and with the mass of 1.2, asking the acceleration. So relationship is F equal ma, and force, what you have to do, this has to be multiplied by 10 to the power minus 3, make it to Newton. So this is 2.6 into 10 to the power minus 3 Newton equal 1.2 into acceleration. So acceleration is given by 2.16 into 10 to the power minus 3. So as two significant figure, we can round off for 2.2 into 10 to the power minus 3 ms minus 2. Clear? Right. The engine designed to accelerate spacecraft is traveling through the space. So it has the mass of 0.75 and it is using this much of mass in 1 second. So student suggestion is given. Small spacecraft engine would not be useful because the acceleration produced is very small. Yes. What you have to do to evaluate this? You have to evaluate. You can think now. What to evaluate is small acceleration. Why? Because this much of small amount of mass is used, right, in 1 second, this much small one. So you can tell the time, you can take the time of usage by having the mass for 9.9 10 to the power minus 8, much smaller amount of kilogram per second. So you get the time as 7.575 into 10 to the power 6 seconds. So this much of long time is used. So when it's long time, what we can say, it is long time and the force that it gives and the acceleration it is produced will be smaller. As you can see with the same equation, force equal change in momentum over time. If it is long time duration, the change in momentum will be big. As it is mass is small, we can say mass is small, we can say that it's for acceleration. Now acceleration is talking about, so the acceleration, we can say acceleration is v minus u over t. So when this is much longer, small acceleration, then this will be a large change in velocity. So let's talk about the safety features. You can say here the crumple zone and the seat belt and the airbags both increase the time of deceleration. When increase the deceleration time, for the same change in momentum, the force, that impact force will be less, so less damage to the passenger.